Hello explorers and welcome to another video. Today we are going to talk about Magic Wormhole. And Magic Wormhole is a tool where you can send a file from one computer to another computer. And you can do it over the internet to a friend that is on a totally different network and everything, or between two computers on the same network. And the only thing you need to know is an ID and two easily spoken words. So let's switch over to my screen here and let's do this first send operation. So if we do wormhole and then send, and then I can do this file that I call add keys, a very small file. When I do that, it will give me an address here that is, it says that on the other end, you should type in wormhole receive 6, which is the ID, Bradbury repay. So if we copy paste this, copy, and we paste it in here, and let's say addition here instead. That was not the correct word, so it will tell me key confirmation failed. Either you or the correspondent typed the wrong code, or a would-be man-in-the-middle attacker guessed incorrectly. You could try again, give both you and the correspondent, the attacker, another chance. And you see that it broke the connection. So we weren't able to send that file through because we didn't have the correct key. And the different word lists has 256 words in one list and 256 words in another list, so which are totally different, which means that we have 65,536 different combinations that could be used here. Then it uses this PACS algorithm, which is a key exchange algorithm, which takes these two words and creates a much larger key that is used in both ends. And so one of the clients creates a key, sends over some information to the other client. That client creates a key, sends over some information to the first client, and then they can exchange data with the generated keys that they both have, because they both have this secret that is never sent over the wire. So that's also an important part of this protocol. You will tell someone these two words, you will not send them through any means. So let's start this over. Let's send this file again. We will get another wormhole code, which is to forever allow. So if I copy paste this as is and then run it, it should say, do you want to receive this file in 96 bits? Yes, and I get that file, I received it, and I wrote it down. And on the other hand here, we can see that it sent it through also. And the interesting part here is that I have a network here between these two computers. These are virtual machines. And in this case, it picked to send the information through the 10.0.2.2.0 network through here. It could have chosen the IP that is available on the internet, which is 192.168.6 on these machines. So if I do address show, this is the internet available address. This is just local network between these machines, and it chose to send it over that local network. So what these clients does is that they create a list of IPs that they know about, and they can send traffic over different networks that they know about, and then choose one of those in order to send the file if both clients are on the same network. If the clients aren't on the same network, but one of them is public, they will use that IP address in order to send the information encrypted. And if both of the clients are behind some kind of firewall, then it will use a relay server. and it will encrypt packages, send it to the relay service, and the other client will fetch those packages from the relay server and then download them down. The problematic part here is that you might be required to, first off, you want to read through the code, which is available on GitHub, open source. It's on GitHub/Magic Wormhole/Magic Wormhole. And there you can read the whole Python code for this client and see that there is nothing strange going on. And I also found on the GitHub page here this public relay pi, where you actually have the addresses used normally for the service, so you know where it actually connects. So it will connect to this WebSocket relay Magic Wormhole IO port 4000 version 1, or the transit relay that will be used is TCP transit Magic Wormhole IO 4001. So if you don't want to use those addresses, then you need to set up something locally that you can go through and go through there. And if you're going to use a lot of packages and send a lot of traffic through to different hosts, then hosting one of these and adding that as your relay instead for the traffic is a good thing, because this server will have a lot of work if it's used for everything. And the other thing that you might want to be sure is that you can trust the server Wormhole IO, because that is what's used when you're not adding any extra information. Then it will send information to that server that you want to send something. It will create these kind of keys, and then the other client will send another request there and say, I have this key, can we create a connection? And then they create this connection through that transit server, and then they can send the data. So the data never goes through that relay, but still you will tell the relay that you want to send something, and you also send keys that way. So if you don't want to do that, you might want to do something locally, and you also might want to have this transit relay where you send the data through. You might want to have that local as well. You could, if you're very kind, create a public transit server that you just add to this network and help out the open source initiative. So other people that needs to send traffic through a transit server could use your transit server. So that's an option as well. But let's say that we have a totally local network. We don't have anything on the internet, and we still want to use this protocol to send files. Then we would need both this service where we can connect to both of the different keys, and we also might need this transit server if we are behind different firewalls and so on. In order to do that, we will need to set up these two services. And I have this relay here, and we can first off look at the packages. So if I search for Wormhole, we can see that we have three different services. We have Magic Wormhole, which is the package in Debian, which is these clients that could send and receive information. Then we have the Magic Wormhole Transit Relay. This is the package which contains the relay for sending packages through. So when you are behind firewalls, you can send it through this transit relay. Then the last thing here is the Python 3 Magic Wormhole Mailbox Server. And why they called it a mailbox server, I don't know. I think that is a very weird name for this. I want to create a key and I want to create a connection between two clients kind of thing. But it's what it's called here. So we could start this transit server with twist transit relay. So if I run that, I will start this on 4001. We could also run this as a daemon by just saying twist D3 and then transit relay. Then it will start that as a daemon in the background. And then we want to start this mailbox server as well. So wormhole mailbox is what we can write there. If we just run twist 3D, we can see here that we have a bunch of different things that we could start. But we want to start the wormhole mailbox. So now I've started those two services. How do I actually use those? Well, I have prepared a URL here. So this is a little bit longer. We will type wormhole. We will have a relay URL, which is this WebSocket URL that I said. So this is the IP of the relay server. Then port 4000, which is the port that this is running on at the moment. And then I want to use version 1 of this protocol. He might create version 2 as well. And then I want to have this transit helper, which is the transit relay. Why it doesn't use the same words for different things, I don't know. It's a bit strange. If we should change this protocol in the future, I would say that this should be transit relay, of course. And this should be a mailbox URL or something like that. Or just call the relay a relay. And then we have this transit helper. We say we want TCP and we want to use this IP and port 4001. I want to send and I want to send this ISO. So if I run that command, I will get that I could fetch this from for disbelief concert. But if I run that on my other server here, it will tell me that it is waiting for the sender. There is no one there because I'm talking to this wormhole IO, which doesn't have that file. It doesn't know about that file. So I actually need to talk to my server again. So I will put in the same information here. And let's see. We will have the relay URL and the transit helper URL and receive. And then I can take this for disbelief concert. And if I type that, I can look at the relay server here and they see that it has connected with the VS Client connection. He has spawned an app ID, creating a nameplate for app ID, spawning the next one, and the client connection. So both of these clients are now connected to this, and I can say, yes, I want to download this file. And now it shows a different IP here. It shows the 192.168.632 instead in order to send this file. But it's still sending it over the local network. So this is a way that you can set up either a file transfer between two computers on your local network or any network that is connected in any way. Either through a known internet address that the developer of this protocol is hosting and paying for. So if you want to help him out, then send some bucks that way. Or you can host it locally and run your own relay server and transit helper server in order to have totally private traffic when you're sending through a wormhole. But I think it's a very interesting technology, and if I ever have a large file that I want to send to a friend, I could tell them that, yeah, let's try wormhole and just give them this address or this key through the telephone or something like that, because I could say for disbelief concert and they know what to type in and fetch the file. So I think this is a very interesting technology and something that you should have in your toolbox if you ever need to transmit a file. And this is what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And If you have any questions or comments, leave them down in the comment section down below, and I really hope to see you in the next one.